Welcome to Slopes of Lines. So what we're going to do is have a refresher from what you learned in Algebra 1. Slope, if you remember, we always count as rise over run. And we also have a formula we're going to show you in just a minute. Rate of change is the same thing as slope, where you do your rise over your run, except for it has some meaning to it. So we'll show you what that is in just a minute. So we're going to start here with the equation for slope of a line. The important part that you need to know is this formula. We still label our coordinates as x1, y1, x2, y2, and our slope is y2 minus y1 over x2 minus x1. So first thing we're going to do is we're going to practice this. And the book will give you a line, and it'll give you a couple of coordinates. What I've already done for you is we have the coordinates, -3, 7, -1, -1. Please notice it has down the x1, y1, x2, y2, right here, and right here. But remember, it does not matter the order of the points. So when we plug it into our formula, remember it's y2 minus y1 over x2 minus x1. So our y2 value should be -1 minus our y1 value should be 7 over the x2 is -1 minus, and remember, do not drop off that extra negative, because when you have the extra negative, the two negatives both become positive. So -1 minus 7 is -8, and -1 plus 3 would be a +2. Now, because it is a fraction, you do need to reduce this. So -8 divided by 2 would be a -4, and that is the slope of the line. So I want you, in your notes, please go ahead and try to find the slope of this line over here. So they give you the two coordinates. I'll go ahead and write down the formula for you again. y2 minus y1 over x2 minus x1, and see what you think the slope is. Okay, the next thing we need to talk about is different types of slopes. You notice a positive slope goes up, negative slope goes down, a zero slope is just a horizontal line, and an undefined slope is a vertical line. Those things are there to help you when you look at a graph to see if your slope is correct, if it's positive or negative. And there is a zero, so if you have a zero on top of a fraction, like a 0 over 5, please know that slope is 0. Or if it's undefined, if it were 5 over 0, you do not leave it as that, you leave it as undefined. So what we're going to do is we're going to take a look at a rate of change. So it says in 2000, the annual sales for one manufacturer of camping equipment was $48.9 million. In 2005, the annual sales were $85.9 million. If sales increase at the same rate, what will be the total sales in 2015? So what we want to do is see how much it increases per year. That's why it is now considered a rate of change, because it has some actual meaning. So when we do this, they give us our coordinates. If you notice, they did not use the year 2000 or 2005. They put a 0 and then they put a 5. So 2000, and down here it labeled it as years since 2000. So we're going to use these coordinates. So the 0, 48.9, and the 5, 85.9. And we're going to plug it into our slope formula. So again, y2 minus y1 over x2 minus x1. So 85.9 minus 48.9 over 5 minus 0. So 85.9 minus 48.9 would be 37. And then, of course, 5 minus 0 would be 5. Now, we do not leave this one as a fraction. We want to go ahead and do that 37 divided by 5. And please remember, that would be $37 million over 5 years. So when I divide it, that would be $7.4 million for every year. So if it wants What will be the total sales in 2015? What we can do, 2015 is 15 years away from 2000, so we can take our 15 times the 7.4, 111 million, and that is on top of what it started in 2000, so we will add in that 48.9, which gives us $159.9 million. So again, rate of change just tells us how much it increased per year. Next thing we want to talk about slope, parallel and perpendicular. So that's how it ties into this chapter. The slope of parallel lines is always the same. So if you notice, slope here is 4 for this line, and for here is also 4. So if the slope of this line's 4 and this line's 4, that means they are parallel. So please write down that parallel lines have the same slope. Now, also, you see we have a right angle, so that means that these two are perpendicular. So if this slope is 4, this slope is negative 1/4. So what we call this is they are negative reciprocals. So perpendicular lines, they have opposite signs, and the fractions are flipped. So like I said, they're reciprocals. So the reciprocal of 4 is 1/4, and then since this was a positive 4, this one is now a negative 1/4. So what we're going to do is we're going to talk about, some graphing with this. Actually, before we get to graphing, how to show if two lines are parallel or perpendicular. So anytime we talk about parallel or perpendicular, we need to always think slope. So what it tells us here is step 1 is to find the slope of these two lines. So FG is at 1, negative 3, and at negative 2, negative 1. We're going to find the slope using the y2 minus the y1 over x2 minus the x1. Again, we have the double negative, so we add those. So that would give us a 2 over negative 3, which to write it properly would be negative 3 over 2. We need to do the same for HJ. So we have the coordinates 5, 0 and 6, 3. So y2 minus y1 over x2 minus x1. 3 minus 0 will be 3. 6 minus 5 would be a 1. So we get a slope of a 1. We get a slope of a positive 3, which then means that there is no relationship between these two. So we'll put no relationship. If we saw the slopes were the same number, then we would know that they were parallel. If we saw that they were the same numbers but they were reciprocals and opposite signs, then I would know that they were perpendicular. Now it does say graph each line to verify your answer. You can definitely feel free to do that, but I'm perfectly happy with just you finding the slope. Just double check that you found it correctly. So that's what the graphing would be for, if you want to make sure that you're doing it correctly. Okay, so let's go on. And we're going to talk about graphing. So the graph on here, we're going to graph a line that contains the point Q at 5, 1 and is parallel to these two coordinates. So again, because we see the word parallel, we are thinking of slope. So it tells me the first thing to do is to find the slope of MN. So again, we need to write down the coordinates. Remember x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. So 1 minus 4 would be negative 3. 2 plus 2 would be 4, so we have a slope of negative 3 over 4. When you graph, the first thing you graph is the point. And then you have to graph your slope from the point. And please remember, slope is rise over run. So I'm going to go ahead and move this out of the way a little bit. I'm going to graph it down here. So the coordinate it says it goes through is 5, 1. So I'm going to go over and go 1, 2, 3, 4, 5, positive 1. Now, I found a slope of 3/4. Because it says parallel, I know it must be the same slope. So if you remember when you graph slope, we count it like a stair step, rise over run. So I'm going to go down 1, 2, 3, so that's the negative 3, and go over 1, 2, 3, 4. And where that stair step ends is where I need to connect my points. And that would be the equation of a line that's parallel to something that has a slope of 3/4. And anything else you graph, again, graph the point and then the slope. So last thing I want you to do is please take a look at this problem and tell me which one of these graphs would be the correct graph for this.